go ahead and slowly start getting started with this. Welcome everyone to this month's CHRN Lunch and Learn series. We're really excited to have you with us today, and we're really excited for the presentation that ACRE is going to be providing us with today. So while you're getting here, make sure you're introducing yourself in the chat and putting in those fun emojis for what you were up to this weekend. Always nice to see who's here and see how we can connect. Green got stuck. Doesn't want to go to the next slide. Keep introducing ourselves, and I will get the slides moving in 1 second.
Oh, Ellen, you are muted currently.
Thank you. The struggles of working up only one screen. I'm on visiting my parents, and I only have my laptop, so I'll go back to where I started, but this is the Coastal Hazards Resilience Network, and as a reminder to everyone, our vision and mission is to strengthen the resilience of the coastal communities in Washington through collaboration, education, and knowledge exchange. So this obviously is one of the examples of that, but we'll also be hosting our drop-in office hours today, and we'll make sure that link is in the chat. So Noah and I will be there from CHRN, and we'll also have cohort representatives there to answer any questions and chat about coastal resilience efforts across the strait. Feel free to say hi, ask us a question, tell us all the different places we should be visiting, what you should know about, suggest the next lunch and learn. You can also connect with us at our website, coastalnetwork.com, or if you just Google CHRN, we come up pretty near the top, although you do have to be careful for the Colorado Horse Rescue Network. That's not us, we are the other one. And you can also go there to sign up for our listserv where you can keep getting information about events like this. This is also a three-way partnership between Washington Sea Grant, the Emergency Management Division, and the State Department of Ecology to bring together the expertise from our three agencies to make sure that Washington's coastlines are getting aligned communication across coastal partners. So the purpose of this Lunch and Learn series is that we have two-way information sharing between us and between the community. The presentation will be about 20 to 30 minutes with a discussion at the end. We will also be recording the presentation, but we will not be recording the discussion portion, so people should be able to discuss. Feel free to discuss whatever they want without fear that this will end up on the internet. When you're asking questions, make sure you use the chat or Q&A function and the raise your hand feature so we're not all talking over each other. And if you have any presenter recommendations, we'd be happy to hear from them. We're especially always interested in hearing from local speakers and how you're addressing your coastal hazards. And with that, I'll go ahead and introduce the team we have presenting today. So today we're hearing from Ecology's Applied Coastal Research and Engineering team. They do lots of great things across the coast, and I've had the pleasure of getting to join them on a couple of their site visits and see how they are measuring and tracking our coast. So I'm really excited to get to share that with everyone today. We have James Dietrich, and he is a senior coastal remote sensing scientist with the Department of Ecology. Gabby Alampay, and she's a coastal geoscientist. And Samuel Giannakos, who is a coastal engineer and the cohort representative from the Department of Ecology. So he works with San Pisa and I on working with communities to bring forward community resilience projects to help make the coast hopefully a little bit safer and a little bit more friendly for the environment. And with that, I will go ahead and turn it over to the ACRE team and they'll get us started.
Awesome. Thank you, Ellen. James is going to drive, but I'm going to start off the presentation. Thank you all for joining us today. We're really excited to share a little bit about the ACRE team. So next slide, James, we'll start from the top. Really quickly, just purpose of this presentation is to introduce you to our the ACRE section, share a little bit of our work, a little bit of the history, and then hopefully we can identify opportunities to collaborate across the C program with Ecology. So our ACRE team, as Ellen said, the Applied Coastal Research and Engineering team, is comprised of 3 units: the Coastal Monitoring and Analysis Program, CMAP, which is the longest standing unit, and previously was the ACRE team that is now renamed. The Shoreline Mapping Unit, SMU, and Coastal Engineering team, both incepted at the same time as the ACRE team over the last year. So outline for the presentation, I'll provide a little bit of a history of the development of ACRE, how things got started, and then we'll turn it over to to Gabby to talk about CMAP. James will talk a little bit about the Shoreline Mapping Unit. I will talk specifically to our Coastal Engineering team, and then we'll open it up for questions and discussion. So really quickly, just going way back and a little bit high level to talk about how the CMAP and ACRE team started. Wanted to share a little bit about the Columbia River littoral cell, and really here just highlighting this complex natural shoreline, lots of sediment inputs, lots of dynamic movement along the coast between Grays Harbor, Willapa Bay, in the mouth of the Columbia River. And you just kind of see how much movement there is in the dynamic nature. And really what's the point of this is that over the last 2 centuries, there's been so much human intervention and recent development within this littoral cell that a lot of these sediment inputs have been disrupted. And what that's turned into is, James, you can hit the next slide, a lot of erosion hotspots popping up along the coast, some that people are familiar with, maybe some others that people aren't. But, with all of these hotspots popping up, it became pretty evident that, there were problems everywhere. And without really this database understanding of what's going on the coast, there wasn't really a way to understand how we can address these erosion problems. So what that turned into is George Kaminsky, and you can hit the next slide, James, thanks. George Kaminsky in 1996 decided to start the CMAP program. And in 97, began first collecting data across various erosion hotspots within the Columbia River littoral cell. You can see some of those in the map on the right. We recently just completed, I think, our 27th year of data monitoring and analysis within the ACRE team. So that's pretty significant. But as it goes with all of this data being collected, there's inherently research and analysis that goes into what do we do with the data. And so it's kind of like a cyclical cycle of data into management planning and decisions, and then the development of coastal resilience projects. So kind of like, this data feeds into a larger process of what do we do with the data? How do we effectively use it to address these erosion concerns occurring across not just the Columbia littoral cell, elsewhere in Washington State. And then once we have a good understanding of what these projects look like, how do we adaptively manage and improve these projects for the future? So just quickly to talk about our recent growth from that inception. The ACRE team has now grown into the 3 units, as I mentioned before. Don't need to spend too much time talking a little bit more about that, but I think there should be one picture. Yeah, there we go. Nice little picture that shows the team. Briefly touch on our areas of expertise. I mean, we cover a whole swath of science and engineering, understanding coastal hazards, coastal monitoring, morphodynamics, GIS and geospatial information, satellite imaging, satellite processing, nature-based solutions, coastal geomorphology, surveying, and remote sensing. So lots of fun stuff going on. And with that, I'll turn it over to Gabby to talk about CMAP.
Thanks, Sam. Okay. Next slide. So we collect a whole bunch of different types of data. Usually we're out collecting survey grade GPS on foot or on ATVs. We also collect boat-based LiDAR. This is primarily done in the Puget Sound, where the beaches are much more narrow and hard to access. We also collect multi-beam echo sounding data for bathymetric data. And recently we just acquired a couple drones for to conduct 3D to get 3D elevations via photogrammetry, and also LiDAR. Next slide. So measurements, what we're looking for is primarily beach elevations. So this would get us to answer the question of what is the shape of the beach and how does it change over time. And so for the beach elevations, these are the different ways that we're collecting usually out on the beach. We have our GPS on backpacks and we're walking profiles. We also do surface mapping on ATVs where we drive around to collect GPS data. And we also have our boat-based LiDAR and sonar over in that picture on the right. Next. So most of our surveys were collecting on foot and on ATVs to get topographic data. So this is the site at North Cove where we pretty much drove and walked all around the area, collecting thousands and thousands of points to get 3D points shown in the bottom of the screen. Next. And with that 3D, those 3D points, we're able to create a digital elevation model or a DEM. And then we come back seasonally, specifically for this site, and survey it again. And we can get multiple digital elevation models. And what we can do with that is that we can difference the digital elevation models and produce a difference map shown at the bottom of the screen. And we can then see a change analysis. So the example here is between 2023 and 2018. And we can see where sediment is being deposited and where erosion is happening in the area. Next. We also collect beach substrate information. So this gets us to answer what is the beach composition and how does it change in space and time. It helps us to understand where the sediment is coming from, how a beach behaves. And there's also some habitat implications, especially in the Puget Sound, where certain forage fish like to spawn in different types of sediment. And it also helps inform research on nature-based solutions. Next page. So we're also looking at cobble mobility in our sites. So where the cobble's moving in along shore and cross shore directions, and how quickly is this occurring, and what are the driving factors. So next page. So at the site, we're collecting, we inserted pit tags inside rocks and then released them into our sites we have some at North Cove and also Claylock, and we are using these trackers to figure out where the cobbles are and where they're moving. And then we've been doing this once a year at those two sites to understand dynamic revetments, both man-made and also its natural form in Claylock Beach. Next. And this is kind of just an overview of our monitoring sites. And as you can see, we have many of them. And the red boxes are where we conduct our seasonal monitoring at work. So we come in 4 times a year to do a topographic survey. And then the black boxes are sites that are more project-based, and we only monitor them when we have the funding. And in the outer coast, our projects are primarily driven by coastal hazards and resilience, whereas in the Puget Sound, they're more about hard armoring impacts and they're more habitat focused. Next slide. So in the Puget Sound, in the Salish Sea, we have collected a variety of types of data. So we have in the picture on the right, you can see we have boat-based LiDAR and topo bathymetric data, multi-beam bathymetric data, and then we've also collaborated with the USGS before to get biosonics information on wheelgrass. And we've primarily prioritize our sites based on active feeder bluffs, restoration areas, armored and unarmored comparison, and forage fish habitat. And funding for these sites include USGS, USACE, the Estuary Salmon Restoration Program, and the South Puget Sound Salmon Enhancement Group. Next. And with the most of our funding has been coming from the Estuary and Salmon Restoration Program. And for that boat-based LiDAR work, where we're monitoring the beaches and the bluffs between 2015 and 2025, these are our list of projects goals. I won't read all the details, but it's basically to quantify and characterize bluff and beach change, assess sediment transport processes, and evaluate patterns along armored and unarmored shorelines. Next. So these are our current projects that we have with the Estuary Salmon and Restoration Program, ESRP. The project on the left is our Beaches and Bluffs project, and the report is expected to come out in December of this year. And the one on the right is our Beach Services project, where the report is expected to come out in March of 2026. And I'll talk more about them in the next slide. So for the Beaches and Bluffs, we collected boat-based LiDAR. So here is a oblique imagery of one of our sites. Next. And then we scanned the area for using our boat-based LiDAR, and we're able to classify all of the features in the LiDAR point cloud. And so here's an example where we have ground, vegetation, large woody debris, and man-made features. Next slide. And we'll usually strip out everything except for the ground surface. Next. And using the bare surface, you can get all sorts of information. This is the point cloud colored by intensity, but we can also get slope and other information out of the boat-based LiDAR. And we'll, like our topographic GPS surveys, we can convert the point clouds into digital elevation models and difference the surface. So this is one example between 2021 and 2016, a difference of the boat-based LiDAR DEMs. Next slide. And then what we can do with this is that separate the site into individual sections. Next slide. And then we can get volumetric information of how much sediment is coming from the bluffs and entering the beach, and where the sediment is going within this drift cell. Next slide. And for beach services, we are collecting several ecological indicators, and we're also measuring the beach widths for different tidal elevations, and also measuring how much of the beach has large woody debris, beach connected vegetation, and overhanging vegetation. And we can see how that is how much there are along the drift cell, and how armored and unarmored shorelines differ from each other. Next, and I'll pass it to James to talk about drones.
Thanks, Gabby. So one of our recent kind of acquisitions for kind of new technology in helping us map shorelines kind of more efficiently and at higher resolutions has been, Gabby and I have been kind of instrumental in starting a drone program in ACRE. And so we're doing both photogrammetry with a small drone, and we recently, this past summer, just got a nice big yellow scan LiDAR system to do high resolution scanning of a lot of our sites as well. So the drone mapping gives us a lot of different kind of options in addition to our ground-based surveys, but they also give us kind of, we can get a wider area context way quicker. So it kind of builds our efficiency in the field, and it also kind of helps us improve our kind of staff safety on some of the places that we survey quite often. But the aerial perspective gives us a different way to look at the beach as well. So rather than just being on the ground with the drones, we can get some really nice, overview imagery to help with kind of public communication, public outreach, and talking about these sites with the public in kind of a more kind of broad sense than just with ground photos or with just maps and other tools as well. And so some of the data that we're getting out, so this is at Westport by the Sea, and their dynamic revetment is, super high res colored point cloud data. That is, we can go out do this essentially whenever we want. Right now we're doing it seasonally with some of our other surveys, but we get the beautiful natural colored point cloud and also a wealth of kind of very, very high resolution elevation information as well with in this case, our photogrammetry mapping techniques. And so sticking with Westport, kind of what Gabby was talking about with our boat-based systems, we can do the same with our drone-based data. And so this is kind of one of our seasonal changes. So this is going from June to September at Westport by the Sea to look at kind of how the beach and the revetment is changing over time. And initially, when you look at those two 3D models, there's maybe not that much change, but when we actually subtract one from the other, we actually see that there is quite a bit of accretion on the beach, kind of over that kind of short time period. So between June and September, we saw about 1.5 meters of additional sand on the lower part of the beach there. And you can also see up on the revetment, there's quite a bit of vegetation growth. That's all the kind of like the little small green dots. There are some little red and yellow spots, which indicate like elevation is lost. And a lot of that is just woody debris moving around. So this gives us kind of, again, a really good, solid kind of wide area picture of kind of what's going on over the entire area, which is kind of something we were missing with our purely ground-based GPS surveys. And then just to kind of plug our most recent acquisition, our new LiDAR drone. So this is a Yellowscan Voyager. So this is about $400,000 worth of kit flying in the air at any given time, which is a little nerve-wracking. But this really helps us improve our efficiency. So this example at the bottom is kind of the east side of our North Cove study area. And with a photogrammetry drone, this takes about 2 flights and about 45 minutes of flight time. With the LiDAR drone, we can get it in about 3 flight lines in about 15 minutes and get the same data density and actually even more information, because now we can actually penetrate the vegetation with the LiDAR and get to kind of bare earth surfaces that we couldn't get with photogrammetry. So we're going to zoom in on just a little part of the dynamic revetment here back in the corner. So this is our colored LiDAR point cloud. And then we can switch it to kind of the elevation map. And so this gives you an idea of how much detail we can get with the LiDAR. So we're getting kind of every individual branch in the trees, which for us as coastal geomorph folks is maybe not so interesting, but it's a wealth of information that we couldn't get before. But the beautiful thing with the LiDAR is, since we're getting through all of that vegetation to the ground surface, we can do a classification like Gabby was talking about with the boat-based system, and you would do with any kind of airborne LiDAR system. So in this case, we're just classifying ground versus not ground, so we can get out the woody debris. In the middle there, you can actually see where we left our ATV on the beach, so that gets classified out as not ground. And then we can strip away all of that, like Gabby said, to get to just a bare earth point cloud. And so this is kind of a game changer for us, because now this allows us at some of these sites to be able to map way deeper, like behind the coast, and start to think about kind of how the topography and kind of the change might be affecting coastal resilience. And some of the projects that we're doing, like right on the beach face, but also in this case, there's this, you can kind of see a drainage ditch back in here that's kind of a remnant before all of the erosion happened at North Cove. And this is actually kind of part of a problem that we're seeing here, is that when it rains or we get really super high tides, that actually fills up with water and actually can pipe back to the road, the highway, and cause issues. So these new surveys are giving us kind of a lot more information, a lot clearer picture of kind of what's happening in the landscape, and not just what's happening purely kind of at the face of this dynamic revetment. All right, so I'm going to switch hats and put on my shoreline mapping hat to come back to Puget Sound now and talk about a project that was funded by the state legislature to kind of do a what we call a coastline condition survey for Puget Sound. And so with that, Senate Bill 5104 was passed in spring of 2023. And so this was kind of the goal of this was to document and map existing general shoreline conditions, structures, and structure conditions. Simply put, this is kind of an armor survey of Puget Sound, kind of a cohesive single methodology armor survey and armor condition survey for the entirety of Puget Sound. And so where we're focusing this right now is on the marine shorelines of the Salish Sea. So all the way out the Straits of Juan de Fuca, the San Juan Islands, and kind of the entirety of Puget Sound. And so the three data products that we're kind of outputting as part of this project are 360-degree on the water photos, so similar to Google Street View. And so these were done by a contractor, either with a kayak or a small Zodiac, with a 360-degree camera mounted on the boat. And so this data is live. We'll share the link in the chat in a minute. But this is available for anybody to cruise around Puget Sound in kind of a waterborne kind of street view world. And you can look at the coast anywhere along the entirety of our project area. The second data product is georeferenced oblique photographs. So similar to Ecology's oblique shoreline viewer that we've had in the past, but we're kind of updating that and we're trying a couple different things. And so the most recent edition in 2024 were some kind of 4-direction oblique photographs from NV5. I can share the link to that viewer. Those are live right now too. And then we're kind of switching gears a little bit for our next round this year and into next year is a new partnership with USGS to do kind of real high repeat oblique photos that kind of more line up with kind of the oblique photos that we did last time or in the past. And those are going to have a lot of new cool applications and that they potentially can be used to do 3D modeling through photogrammetry of, I was going to say the entire coast. We're not going to do all of that processing, but the data exists for those to be processed potentially into photogrammetric 3D models, which would be cool. And then kind of the last and most important is the shoreline condition survey. So we redigitized kind of a hybrid shoreline along the entirety of Puget Sound, like I said. And then we were going through and attributing all of the different shoreline modifications that exist along the shore. So the reference line that we decided to kind of use was not any of the existing shoreline data sets because a lot of them were too coarse or not exactly what we needed. But we digitized between 1 to 300 and 1 to 500 scale, and the line that we kind of digitized approximates ordinary high water. So it's not an official ordinary high water line, but getting there. And then the attributes that we're looking for are, armor. Is it armored or is it not? And then if it is armored, what are the materials? What is the condition? And then that gives us kind of a very broad view of how the shoreline looks at kind of this moment in time. And then the goal of the whole project is to update this every 2 years so that we'll have we'll be able to change detection across all of Puget Sound to see where armor is either gained or lost, and hopefully help out with coastline or shoreline management, planning, resilience efforts, even kind of getting into the habitat realm to look at where armor is. So this is just kind of an example of some of the different shorelines that we could have used. And then the red line is actually our digitized shoreline that is, again, ordinary high water. And then also why we're calling it a hybrid line is that it's actually capturing some of the armor that's kind of jutting out beyond ordinary high water as well. But there's a lot of different shorelines that we could have used, but again, we decided that it was going to be easier and more accurate to just digitize a fresh line that we can use over and over and over again to help us detect change a little bit better. So just some examples of some of the different areas that we've been working in. So this is Cultus Bay on Whidbey Island. And so there are a couple of different shorelines here. In red is our reference line that we digitized. White is the current DNR shore zone line, which a lot of people use. And then the blue is a CFS tidal restrictions and tidal influenced habitat mapping project. And so we're kind of in between the hyper detailed CFS line and the really, really coarse shore zone line. So kind of a good mix of the two. I won't go through this, but you guys can look at this. This is kind of the list of attributes that we're looking at for all of our different, all the different kind of shoreline segments that we've digitized. So this is quite a bit of work, as you can imagine, but we are, I think, 87% done. We just have San Juan County left, and that's relatively unarmored, so it should go fairly quickly to get this released in the next couple of months. So just some other examples of, this is in Mason County, and so you can see kind of the armor type classifications that we now have on our line. So things like rock, concrete, mixed materials, so probably rock and concrete or rock and kind of dimensional lumber. But that kind of gives you an idea of how detailed we're getting with our line versus kind of the old beach strategies line that a lot of people have used in the past. And then this is just an example of some of the data that you could get out of it for the South Sound. So this is kind of pulling out in GIS, kind of shoreline armor by type, so by kind of percentage of length. And so, you know, in the South Sound here, we can say that roughly 63% is not armored and about 36% has some sort of armor on it. So this will be, you could make this map for the entirety of Puget Sound in the coming months, which will be pretty amazing. So the applications for this are kind of very, very broad, but compliance and enforcement has been a big kind of push is to use this for that. But restoration, prioritization, documentation of habitat, you know, things like other planning applications, permitting, engineering design, and then ultimately, once we have multiple data sets online, we can start to do some coastal change detection and kind of feature detection, feature change detection as we move forward. So I'll paste all of these links in the chat in just a second, but this will be to our shoreline mapping page. So this is where we're going to provide updates on our different products. And then there's also the links to the 360 viewer and the 2024 oblique viewer. I'll pass it to Sam.
Cool. Thank you, James. Last, I'll be talking about our coastal engineering unit to bring us home. Really, I think, you know, conceptually, the crux of it, and James, you can go to the next slide. The crux of everything is, you know, James and Gabby did a really good job of talking about the different techniques that the ACRE team is using. And the engineering is like, how do we take that information, use it for projects, and turn it into something usable for future implementation. So on the engineering side of things, you know, there's a lot of applied research for nature-based solutions in the outer coast and also in the Puget Sound, and then alternatives to hard armoring in Puget Sound. Some other services we offer is direct technical assistance, reviewing permits, kind of like the consulting services as the bottom right says, like reviewing design drawings, kind of vetting engineering processes, helping to support grants, vulnerability assessments, resilient project supports, and then guidance and training, turning this information into usable products for the future. I'm going to talk about some examples of some applied engineering on both the outer coast and the Puget Sound. So first we'll start on the outer coast. James and Gabby alluded to these cobble berms or dynamic revetments. This one specifically here is the Westport by the Sea dynamic revetment that James showed, but you can see on the map there's several others. Next slide, James. Before I get too far into that specifically, I want to also highlight the naturally occurring cobble berm in South Beach near Kalaylock. If anyone else has been out to that area, you may be familiar with this cobble berm. It's a site that we also regularly monitor, and it's kind of like the poster child of a natural berm to compare all of the monitoring we're doing on the man-made engineered revetments to have like a baseline for understanding of how is it performing, how should it look, how should it adjust in the future, how can we mimic that to try and be the most effective. So getting back to Westport by the Sea, before we go there, I think, the other big thing to highlight about engineered cobble revetments is that there's not strictly a design guidance for them right now. You can see the Graveyard Spit North Cove, Westport by the Sea, and the Empire Spit dynamic revetments. They all have very different designs, different ocean facing slopes to them, different materials used, multiple layers involved, different back dune structures. So highlighting here, there's really no guidance or engineering requirements that are put into it. It's kind of just, site by site at this point, and we're just trying to understand how each of them performs and how to kind of mold what we're learning from individual projects into something usable. Now getting back to Westport by the Sea, I think you can hit the next one on this one. It might be a repeat. Yeah, so this is the construction of it. Our partners over at Blue Coast were really helpful in this one. So I know a couple of you are on the call. So thank you very much. But yeah, just quickly, you can see, pretty shallow slope, 5-to-1 with two types of material, a pit run in the bottom core, and then also cobble material at the top. Just wanted to highlight the construction of it just as we get into the next little bits here. What we've been doing at Westport by the Sea is James, you can even skip this slide. What we've been doing is monitoring the performance of the beach. James showed some great data about how the beach is accreting, but a little bit more related to the berm itself. These cross sections can give us a lot of information on how material is moving in and out of the berm, areas where we're seeing elevation depressions, areas where we're seeing accretion in and around the berm. So here's just shows us how we're monitoring it. And then the next slide will show the comparison of two surveys. So Gabby did a great job of explaining how do we produce DEMs, digital elevation models. If we overlay two DEMs, you can see between two surveys the major differences, and how this is really helpful for this project is indicators as to where the material is moving from and where future maintenance is required. So you can kind of see there's two major hotspots where we've noticed cobbles moving the most. And I think the next slide shows kind of the visual cues of this that replicate what we're seeing in the modeling. You can kind of see like some of that outer cobble material is being exposed during high wave environments in the winter. And then, the Westport by the Sea Homeowners Association comes back in and uses the information we're collecting to identify places and areas to replace and replenish that cobble for maintenance. Next, I'll talk a little bit about what we're doing in the Puget Sound. So obviously on the outer coast, it's a different wave environment. There's a lot of high energy, large swells, and it's focused on coastal hazards. In the Salish Sea and the Puget Sound, you're dealing with more relatively low energy as compared to the outer coast. The shorelines are much more highly developed. They're a little bit more complicated in terms of erosion processes and functions, and there's more of a habitat focus with relation to shoreline functioning as well. So one project we're just kind of kicking off right now is a multi-phased approach to addressing hard armoring in the Puget Sound. Right now we're kicking off phase 1 of a multi-phase approach, as I said. This one's focusing on really gathering as much information as we possibly can. And partly it's related to what James and Gabby had shared earlier about going through and mapping out all of the shorelines in Puget Sound, synthesizing all of that information, And then that'll feed into the future phases where we'll start to monitor and evaluate how those shorelines are responding over time in a time series fashion. It'll lead into demonstration projects where we'll implement future projects that from what we've learned through our monitoring and evaluation, and then hopefully through that process develop some guidance for how to do this in the future. And then very quickly, I know we're shorter on time. I just wanted to talk about how the cohort, because I know a lot of you know about the cohort, how that fits into the mix. I don't need to get into the definition of it, but the next slide shows a really great summary of this process of a project development over time. Yeah, there you go. So the benefit of having me being involved in the ACRE team and also the cohort is that there's very different, all these many interjection points of where I can bring ACRE's expertise into the mix and kind of have those like little touching points along the way, and provide a little bit more technical assistance to the communities where either the cohort's not able to provide or ACRE's doing all this other work and unable to devote more attention to. And then how that looks is, in the next slide, we have a nice map that shows where we've supported various communities and projects. The big takeaway is that ACRE has been involved in some capacity in many of these locations as well, and bringing a lot of the work they've either done or are doing to the development of these projects as well. So yeah, that's all from us. We can open up for some questions. I know there's been some in the chats, but if anyone hasn't had their questions answered just yet, feel free to ask them now too.
Thank you so much for that presentation. I talk to Sam almost every day, and I learned a lot about ACRE from this, and I'm excited to go poke through the street view.